Welcome to Computer Vision Zero to Production from PI with Mike. Object detection is one of the most powerful things you can build with deep learning. By the end of this series, you would have trained a model that can identify 6 types of fruits in any image. Wrap this in a production API, containerized it, and deployed it to a cloud server. Every step, no shortcuts. Here is the full pipeline. We collect data and annotate the data, train a YOLO model on a Google Cloud notebook using free GPU. Export the weights, build a FastAPI application that accepts image uploads, and return bounding boxes with class labels and confidence scores. Containerize it with Docker and deploy to Hetzner Cloud. The model detects 6 fruits: apple, banana, grapes, kiwi, mango, and orange. We are going to use Python throughout this program or throughout this series. PyTorch and Ultralytics for training and inference, RoboFlow for the datasets, MakeSense.ai for annotation, which is free browser-based, no account needed, FastAPI for the API, SQLAlchemy for the database, Hetzner for cloud deployments and object storage, Docker for containerization, GitHub Actions for CI/CD. One of the most important things in production applications is principles like clean architecture, solid principles, which is important because it makes your development to production life easier and also makes your application maintainable and easily onboardable for new participations. So our project follows clean architecture principles, the same pattern for our supervised ML series. The business logic lives in core SRC. The infrastructure concerns like the model runner, the storage, database all live in infrastructure layer. Domain interfaces and entities lives in domain. The DI container wires everything together. The main.py at the root is the FastAPI entry point. So let's set up our environments. For this, we'll be needing Visual Studio Code, which you need to install. And you can install that by, let's say, going on Google and searching Visual Studio Code, download. And you can download for your hardware, be it Linux, MacBooks, or Windows. So as you can see it here. So you open your folder and you select where you want to work from. So you open a terminal and you run a command, Python -m, which means you want to create a virtual environment, which is what the VENV is for, and we call this our CV environment. We also need to activate our environment, which would be source CVENV, then bin activate. If you are using Windows, the command would be different. So for Windows, you would have used, like, after you run the Python mvenv cvenv, you would have to run, let's say, cvenv, then scripts, then activates. This would not work here because I'm on a Linux terminal, but this is for those of us using Windows. Right, so then after that, we need to install some important libraries. You don't have to worry about them now. We are going to see their use cases and where they come in as we go. So we can just as well create a file here called requirements.txt. .txt where we can list them out, or let's say just install pip install, then Ultralytics. So Ultralytics is like the open source library for us to use, train, predict YOLO models for either computer vision in our use case, but they also work for segmentation models. They also work for classification models using images and so on and so forth. So we can see that, yeah. So Ultralytics GitHub. Let's say you want to research more into them, you could just find them out here and look into their Ultralytics library. So here you are going to find a lot of details about how on the evolution actually of Ultralytics over time. So you would see the latest model YOLO 26. You can also see that they support segmentation, they support semantic segmentation, they support classification, they support post-estimation, they support objects or oriented bounding boxes, and so on and so forth. It's a vast community. So you can also read more about their Python library by saying Ultralytics PyPy. You can find them here, and also read through the documentation as you require. So back to this. So then we talk about Torch. Is also an important library for our models. We also talk about Torch Vision. We also talk about FastAPI, which we want to use as our API. We also talk about Uvicorn to manage the runtime of our API. Aside from that, we also need to install SQLAlchemy. We also need to install SQLAlchemy binary, which is one of the libraries to connect or to actually manage our database along with SQLAlchemy. We also need Pillow for image manipulation in production. We also need Python multipath. And for cloud services, we need Boto3 to connect to storage buckets. We need Pydantic settings for our API settings, and we need PyTest for testing our logic, and we need Black. So we could do it like this, or we could just come here and paste it to our requirement.txt and have it on a multi-line pattern. So we move this, we move this, we move this, we move this, we move this. This is Python multipath, so that was wrong. We need Boto3, we need Pydantic settings, we need PyTest, we need Black. Eventually we are going to need AIU Boto3 for asynchronous processing. And what else? I think we are going to need asyncpg. Yes, for now. So we might eventually need more libraries than this. These are what I can think of for now, but as we proceed, we are going to see how that goes. So we could install this, or we could just run pip install our requirements.txt. You can see when I was listing out the packages on a single line, I didn't have to use the R for recursive, but now that I'm providing a file, I have to add an argument to that it needs to install all the libraries in the requirement.txt. So while that is installing, we can start setting up our projects. So let's create our main.py for the FastAPI application. We need our src directory, and in our src we need the config layer where we would have our API settings. For the settings.py, we need to have the container, our DI container, to wire up the entire application. Inside SRC, we would also have our core layer for interfaces, for inference and review pipeline. We need to have our core. We need to have, in SRC, we also need to have our domain layer for interfaces. We would eventually see how all this wire together and how they all contribute to making our code clean and loosely coupled. So in SRC, you also need to have infrastructure. Structure, like we said, that is going to hold everything we need to speak with other things like databases, storage buckets, cloud services, and so on and so forth. So in infrastructure, we can have our database, we can have our ML parts, yeah, we can have our storage, we can have inside infrastructure, we can have repository for our SQLAlchemy queries, or repository. We can also have services that would connect everything together. Services that would make sure we can use our repository and our storage, and also in some cases our repository and our database. So we would see how they all wire together. So aside from this, aside from our SRC, we will need to have like our data part, since this is an ML project. No, we need to have it on the project roots. We have our data. So in our data, we are going to have our annotated data. We are going to have our notebooks. No, in our data, we are going to have our raw data, annotated data, yes. And we would also have, like, let's say, our process data. We would eventually see how they all come together. Aside from that, we are going to have our notebooks for, let's say, analysis, training, and so on and so forth, but not in data, in the root directory. So let's say we have our notebooks, and let's say we have our scripts, which would see how they all wire together. So what else? We might need to also have our model weights. So I think that is like a solid setup for now. We are going to expand as we proceed. So in essence, we have our container.py, the only place that knows about interface and implementation. And I think we've not added something to our SRC, which is our API layer, which would have our routers and our schemas. Routers.py, our API schemas.py. This is and yes. So yeah, we can have our base.py, which would hold our database important details. We also have our session, which would use to manage our session in connection to the DI container and our database repositories. You don't have to worry about that for now. We'll get to them as we proceed. So once again, we are going to have our container, which is the only place that knows about interfaces and implementations. We are going to have our scripts, where we can have the sample data, batch our data, annotate data, merge our data, and split our data, and so on and so forth. So in our next videos, we are going to, but before we talk about our next video, one of the important things I've not touched on is we are going to be using Colab Notebook for training. It is free on Google. We are going to have like a GPU that we can use on there to train our model, and we are going to see that as we proceed. So after we train our model, we are going to export them to our local environment to do every other thing that we need to do. In our next video, we are going to discuss about the fundamentals of computer vision. What does the model actually see when you give it an image? What is a bounding box? What is an IOU? And why does this matter in evaluation? What are mean absolute precision? And for IOU, that is the intersection over union. What is our mean absolute precision? And other metrics that we're going to need as we proceed. All of that before we write a single line of training code. See you in our next video.